Hello and welcome again to my physics topical video short lectures. Today's is a follow-up to a previous video. We are going to be talking about significant figures a little bit more. In the previous video, which you should watch before this one, I simply introduced significant figures and explained how to determine how many significant figures a number has and what the rules are for significant figures and what it was they did. In today's video, I want to go into the rules for how to sort of know how many digits to retain or how many significant digits to report for numbers that you've calculated from your original numbers. As a sort of conceptual example of this, let's say that, again, you are in a room like the one that I'm in, and this time, instead of just measuring a wall, you decide that you need to figure out how big the floor is. Okay, so you want to figure out what the area of the floor is so you know, for example, how much carpet or tile or whatever you need to order to cover it is. So how do you go about doing that? Well, one way is I'm in basically a rectangle shaped room, so you would measure one wall, you'd measure the other wall length, and you should multiply those two lengths by each other to get the area. Okay, so then we come up with the question, how many significant digits do we report, given that I only know the two walls to a certain level of precision. I can't know the area of the floor to infinite precision if I only know each wall to, say, 3 digits worth of precision. And this is also true for if I'm adding or subtracting, that kind of thing. So for example, maybe I want to know how much wallpaper I need in order to cover the walls. So there's 4 walls. I would basically just measure the length of each wall and then add all those lengths together, and that's the length of wallpaper that I would need. I might also then subtract from it things like I have a door, I have a window, and I have a whiteboard. So, maybe subtract some length for those things for the wallpaper. Of course, the whiteboard also comes off the wall, so maybe not that one. But the window and the door are fixed, so I would need to maybe subtract those lengths. So what are the rules for all that? And that's what this video is about. There's actually kind of 2 sets of rules. One set of rule goes for adding and subtracting. The other set of rules goes for multiplying, and we'll start with the rule for addition and subtraction. In some sense, this one is, let's call it least precise number or least well-defined number rule. So you could think of it as the largest, smallest place rule. Because basically the rule for addition or subtraction, they share the same rule, is that you look at each number in the sum and you figure out which one has the largest last significant digit. So you could also call it largest last, or largest last significant digit. And by largest, it's really the largest place, not the largest number, but the largest place. So sometimes it's easier to just go by example. Let's say that I have 2 numbers that I want to add. I have 1,001, and to that I'm adding 900. Let's say that for this one all digits are significant, and for this one only these 2 are significant. So you could also think of this as 1.001 times 10 to the 3 plus 9.0 times 10 to the 2. Okay? So I want to add those 2 digits. If I just add these 2 numbers together, I might report this as 1,901. The thing is that this 900 is only precise out to the tens place. So this is tens place. This one is to the ones place. Now the tens place is the largest place of the last significant digit in this number. So it is larger than the ones place. So this must be can only know to nearest tens place, thanks to this number here. So this sum with significant figures we would say is 1900, or in other words 1.90 times 10 to the 3. Okay, so that's the basic rule for addition and subtraction. You just look at whatever place has a significant figure is the largest place for the last significant digit in each number, and then whichever one is the largest, that's the one that determines what we can know the entire sum or difference to. For multiplication and division, it's actually easier to just state the rule. Just count. So count number of sig figs in each number. Whichever has the least is the one that determines it. So you could say it determines the total number of significant figs, sig figs. So for example, like let's say that I have 1,245 times 367. So this one has 1, 2, 3, 4. This one has 1, 2, 3. Therefore, since this one has fewer, product has 3 sig figs. So if I were to actually do this product, so I take a calculator, I put in 1245 times 367, I get, if I just multiply the two numbers together, I get 456,915. Okay, but I have to have to 3 significant figures, so this gets rounded to 457,000, or in other words 4.57 times 10 to the 5th. Okay, so those are your basic rules. So there's one other thing that we should do, which is what about order of operations? And the answer is the significant figure rules are going to follow the basic order of operations for the problem involved. So if you have, say, 15 plus 250 plus 17 minus 120, and then you want to divide that by, let's say, 12, or let's divide it actually by something bigger. Let's divide it by like 12.00. So we got 4 sig figs down here. You have to start off by adding up everything here in the numerator. All right, so 15 plus 250 is 265. Plus another 17 means that now we're at 282. Minus 120 means that we have 162 over 12.00. But if you look at these, this one right here and this one right here are both ambiguous. But suppose 250 is 2.5 times 10 to the 2. Okay, and this one right here therefore won't matter, but in principle we could also say that 120 is 1.2 times 10 to the 2. Okay, that means that these are not significant zeros. So the nearest digit for these is the tenths place. So this number right here becomes approximately 160 over 12.00. In other words, there's two significant figures on the top. Now with that said, when you go to do the work on your calculator, you can retain the 0, or you can retain the 2 in the 162 and round at the end. But you now know that there are only two significant figures in that top number, and therefore you're going to end up with two significant figures in the total quotient. So this is 1.6 times 10 to the 1 over 1.2. Sorry, times 10 to the 2. 1.2 times 10 to the 1. So 1.6 over 1.2 is actually 1.25. So we would say 1.25 times 10 to the 1, but you only get to keep two significant figures. So this 5 goes away and you end up with about 1.3 times 10 to the 1, or if you'd prefer 13. Okay, so you retain only two significant figures even though the one on the bottom had 4. At this point, maybe a brief your turn to play is in order. So a brief your turn to try it out, quiz yourself, examples type thing. All right, so here are sort of 3 problems for you to try it out on. And you might want to pause your video and work each of these out on your own at this time before I work out the solutions for you. This top one, sorry, I've written in a maybe confusing way because I'm mixing between scientific and standard notation. The point was just to show you that yes, this 0 is significant and any other zeros in the numbers wouldn't be. In other words, this number right here is 120,000, but these are significant. This number right here is 145,000, with these being significant. So go ahead and pause your video, work these out, and then hit play. All right, so this first one right here, if we were to add and subtract the numbers, so again, I'll use the calculator. We have 120,000 plus 145,000 minus 1,975 plus 43,675. And if you just strictly enter all those numbers into the calculator, you get 306,700. And so we want to know what of these digits is significant. So we come over here and we see that this one right here is thousandths place. So oops, thousands. This one also is thousands. This one is ones. This one is ones. So even though these two both have more significant figures than these two, since it's a sum, we're looking at which one has the largest last place, and the answer is these two do. So we can only know the final answer to the nearest thousand. So this is your thousands place, 1,000s place. So this number you would need to round to about 307,000, or in other words, 3.07 times 10 to the 3. All right, next number. We have 1,275 divided by 25. So 1,275 divided by 25 is 51. And we look at this one. This top one has 4 digits. The bottom one has 2 digits. Our total, therefore, should have 2 digits. So this one actually is correct. We don't need to do anything further. So has correct number already. Now, if we had another similar sum, let's say 12,000, or let's say 127,525, and we were to divide that one by 25. So a similar number, 127,525 divided by 25. This one, if you were to calculate it, would be 5,101. But this right here only has 2 sig figs, so 2 . So this right here would actually round off to 5,100, or in other words, 5.1 times 10 to the 3. Okay. And again, this works for multiplication as well. I've kind of done all division problems. If I were to multiply these two numbers, so if I were to do 25 times 1,275, 25 times 1,275 is 31,875. 31,875. Again, this right here has 2 sig figs. So, and this one has 4. So my answer would need to be 32,000, or in other words, 3.2 times 10 to the 4. Before I do this last one, a little side note. You may be wondering, like, what about these times 10 to the 5s up here? Does that count? The answer is no. The times whatever power part doesn't count as significant figures. Similarly, there's some numbers where you have like a fraction, an exact fraction in front of it. Like if you want to know what is the radius of a circle, given the diameter, the radius is half the diameter. That 1/2 doesn't count for significant figures because we know that it's exactly half the diameter. So the 1/2 part is like having infinitely sig figs, and it's only the diameter then that would determine it. Okay, so let's look at this last one. So I have 14 plus 86, which is, for what it's worth, 100. Divided by 125 plus 375, which is 500. Now, how many significant figures should this go to? Obviously, like these, 100 over 500 is 1/5, or is 1/5, is 0.2. But we now ask, are these zeros significant, yes or no? And the answer is yes. I added something to the ones place to something else to the ones place. So I'm significant on the top to the nearest 1. So this is significant. So therefore there's 3 significant figures on the top. And the same is true on the bottom. Ones place is significant. So I actually should have 3 significant figures, and so my answer to this one is not just 0.2, it's 0.200. All right, that's all for this little video. Thanks for watching, and I hope it helps you to understand what to do with significant figures.